In Lesson 14, we'll be looking at equivalent linear expressions. In previous years, you've learned how to write expressions in many different ways. We want to take a look at this problem and then explore it. Micah and 3 friends bought a total of 4 bags of pretzels and 4 drinks at the snack stand. If a bag of pretzels cost X dollars and drinks cost Y dollars, what expression could you write to show how much the friends spent in all? We're going to answer a few questions about this problem in order to explore it. If we suppose that each friend bought 1 bag of pretzels and 1 drink, we need to write an expression to show how much they spent in all. Well, each friend bought a bag of pretzels and a drink, and 4 friends did this, so we can create the expression x plus y plus x plus y plus x plus y plus x plus y. Now if we suppose that one friend bought all 4 bags of pretzels and another friend bought all 4 drinks, we can write an expression that shows that total cost. Our first friend bought 4 bags of pretzels, so 4x, and our second friend bought 4 drinks, so 4y, and when showing the total cost, you would add them together. So our expression becomes 4x plus 4y. If we suppose one friend decided to pay for a bag of pretzels and drink for all 4 of them, what expression could we write to show that total cost? The one friend is going to buy every person a bag of pretzels and a drink, and they are going to do that for 4 people. So this expression now is 4 times x plus y. If we wanted to explain how the first 2 expressions are related, we could look at what they have in common. Both expressions have in common the fact that they contain 4 x's, or 4 bags of pretzels, and 4 y's, or 4 drinks. And they are being combined through addition as well. If we took a look at the last 2 to see how they are similar, we could again say that they contain 4 x's and 4 y's. We could even say if you distribute 4 times x plus y, you would get the expression 4x plus 4y. Now if we want to find out more, we can say that all expressions have the same value if they are equivalent expressions. So it's important for us to identify what equivalent expressions look like. Numerical expressions such as 8 plus 2, 15 minus 5, 40 divided by 4, and 2 times 5 are all equivalent. They are all equal to 10, which makes them equivalent to each other. So they say the same thing, they just look differently. If we want to take a look at the following expressions to see that they are all equivalent, we can take a look at what makes them equivalent along the way. And these are the same expressions from the last section. If we wanted to show that expression 1 is equal to expression 2, you can use the commutative property and the associative property of addition to group and change the order of the terms, which means x plus y plus x plus y plus x plus y plus x plus y will now become x plus x plus x plus x plus y plus y plus y plus y. So we're taking our like terms and we're rearranging them to be next to their other like terms. This is through the commutative and associative property. If once we've rearranged them, we take a look, we see that we have 4x's and 4y's. So we have 4x plus 4y. This is the same expression as what we had in expression 2. To show that expression 2 is equal to expression 3, you can use the distributive property to factor 4 from both terms of the expression. It's important to know what it means to be a factor. And a factor just means that you are a number you can multiply by, or a multiple. So given the expression 4x plus 4y, we're asking, how do we factor that? 4 times what will give us 4x plus 4y. If we know our factor needs to be 4, what will we multiply by to get 4x? Well, x. And if we need to get 4y, what will we multiply by to get 4y? You would multiply by y. So if you took this and redistributed, you would come up with 4x plus 4y again. And this is what our expression was for expression 3. Simplifying the expressions is not the only way to identify that they are equivalent. You can also evaluate the expressions to see if they are equivalent. If you know that a bag of pretzels costs $2 and a drink costs $3, you can substitute 2 for x and 3 for y into each of the 3 expressions above. So x plus y plus x plus y plus x plus y plus x plus y would become 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus 2 plus 3. 2 plus 3 gives us 5, so what we are really looking at is 5 plus 5 plus 5 plus 5, which equals 20. We can do the same for expression 2. 4x plus 4y, if you replaced x with 2 and y with 3, would become 4 times 2 plus 4 times 3. 4 times 2 is 8, and 4 times 3 is 12, so 8 plus 12 gives us 20. In the third expression, we would substitute again 2 for x and 3 for y, so our expression would now look like 4 times 2 plus 3. Our order of operations tells us that we would simplify inside those parentheses first to get 4 times 5, and 4 times 5 would give us 20. We've already talked about the distributive property, and many people wonder about 4 times 2 plus 3, whether you have to go ahead and simplify inside first or not. And really it doesn't matter, because you could distribute the 4 as well. 4 times 2 gives us 8, and 4 times 3 gives us 12. So 8 plus 12 gives us 20. And again, that is the same number as we came up with before, showing that all of these expressions are equivalent to each other. Now if we reflect, we're being asked to write 2 other expressions equivalent to 4x plus 4y. We've already talked about 4 equivalent expressions. We have said in recap that we are looking at x plus y plus x plus y plus x plus y plus x plus y. That is one expression. From there, we used our commutative and associative property to create x plus x plus x plus x plus y plus y plus y plus y. We have said that there are 4 x's and 4 y's, which is actually the expression in our problem. And we have even factored to come up with 4 times x plus y. So in this case, when we're asked to write 2 other expressions equivalent to 4x plus 4y, we're being asked to give expressions that we have not already talked about. And you can look at these and start combining them in a variety of different ways. 2 ways that stick out in my mind are to combine some of your x's and to combine some of your y's. If you did so, you might look at 2x plus 2x plus 2y plus 2y. The important part is when you simplify this that it becomes equivalent to 4x plus 4y. And in this case it does. Another thing that we could look at is our factors. If we had 4x plus 4y, 4 and 4 are both divisible by 2, so you could factor out a 2, in which case, in order to get our 4x, you would multiply 2 by 2x, and in order to get our 4y, you would multiply 2 by 2y. These are 2 other equivalent expressions for 4x plus 4y. They are not the only 2 others, they are just 2 that you can use. Now let's take a look at some models of how this can be used. We're going to read the problem below, then explore different ways to write equivalent expressions for the perimeter of a square. The length of a side of a square is c minus 9. 3 students wrote 3 different expressions for the perimeter of this square. Are the expressions equivalent, and explain why or why not? The best way that I know how to go about these problems is to make sense of it by reading through the wording carefully. We're looking for the perimeter of a square, and a square has all sides that are the same. So the perimeter is the border. You'll be adding all of the sides together. Or because it is a square, all sides are the same, so you could take the side length and multiply it by 4. So 4s. Once you do that, you know that the side of the square is c minus 9. So everywhere you see the side, you would replace it with c minus 9. You would do the same in both scenarios. So now we could also say that perimeter would be 4 times the side length. These are 2 expressions that could be used. This is the best place I know how to start. Now we're going to start exploring what the 3 students in the model said. Miguel wrote the perimeter as a sum of the 4 equal side lengths, saying that the perimeter is c minus 9 plus c minus 9 plus c minus 9 plus c minus 9. We said the same thing in what we did to make sense of the problem. Therefore, Miguel is correct. Then we look at Jessica. Jessica rearranged the terms, putting the like terms together. So in our Miguel example, we have c, 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 and c that are all like terms, -9, -9, -9, and -9 that are all like terms. So when we rearrange them, we are looking at c plus c plus c plus c, and negative 9 minus negative 9 minus 9 minus 9 minus 9. We cover all 4 C's and all 4 negative 9's. So Jessica is also correct. Now looking at Petria, she multiplied the number of sides by the length of a side, giving perimeter is equal to 4 times C minus 9. That is the second way that we came up with for calculating the perimeter based on making sense of the problem ourselves. So we have established that all 3 answers are expressions that are equivalent to finding the perimeter of this square. Now let's make some connections about what we just said. Now will you use properties of operations to decide whether or not all of the expressions are equivalent? We want to look at Miguel's expression and Jessica's expression. We want to know what is the same and what is different about them. Miguel and Jessica both cover all 4 sides, giving us 4 C's and 4 negative 9's. That is the same about them. What is different is their arrangement. Miguel kept the sides together as is, C minus 9, and Jessica regrouped to put all of the like terms together. So the arrangement of the terms was different. When we simplify Miguel's expression, though, if we still have 4 C's, then that is 4C. And if we have 4 negative 9's, then that is negative 36 overall. If we simplify Jessica's expression, we have C plus C plus C plus C, which is 4C, and negative 9 minus 9 minus 9 minus 9, which is negative 36. So you can see that the equivalent expressions are 4C minus 36 both. So, yes, the expressions are equivalent. For number 4, we want to use the distributive property to rewrite Petria's expression. And Petria's expression was 4 times C minus 9. The distributive property requires us to multiply 4 times C and 4 times negative 9, giving us 4C minus 36. So is Petria's expression equivalent to the other 2? Yes, they are the same. Now can you think of another way to show all 3 expressions are equivalent? We have talked about simplifying them to see their equivalency, but one other method that we've talked about in order to check for equivalency is to evaluate the expression for some number. And we do this to see if they simplify to be the same thing. So for example, we could substitute some random number. In this case, I'll choose C equals 2. So we could substitute C equal to 2 to see if they simplify to the same number. Again, I just chose a random number. You could choose any number. It does not have to be 2. Then we want to know, how could you use properties of operations to decide whether or not expressions are equivalent? The properties that we've talked about are commutative, associative, and distributive. So you can use those properties We're going to use those properties to see if they simplify to be the same expression. Now let's try some examples. We want to use what you just learned about equivalent expressions to solve these problems. Number 7. If the perimeter of a square is given as 12x plus 20, write two different expressions to represent its perimeter. Use factoring for one way. So we're talking about the perimeter of a square, and we want to use factoring. From this, we can identify that perimeter is going to be the side plus the side plus the side plus the side, which is the same thing as the perimeter is equal to 4 times the side length. We could start with factoring. We know that we have to multiply by 4 because there are 4 sides. So we're saying 4 times what will give us our overall perimeter of 12x plus 20. So 4 times what gives us 12x? Well, 4 times 3x. And 4 times what will give us 20? 4 times positive 5. So our factored answer would be the perimeter is 4 times 3x plus 5. After identifying this, we know that the 3x plus 5 would be our side length. We can now substitute that into our other version of our perimeter formula, stating that 3x plus 5 plus 3x plus 5 plus 3x plus 5 plus 3x plus 5 will give us our perimeter. In number 8, we want to write two different expressions equivalent to 8d minus 4, and we want to use factoring for one way. This does not give us any specific guidelines as to how to factor, so this is where it's important for us to know what a factor is. If we are factoring 8d minus 4, we want to look at our 8 and our 4 and figure out what's a common factor. Both of these numbers are divisible by 2. Both of these numbers are also divisible by 4, so you could use either. I'm going to choose 4. So 4 times what will give me 8d? Well, that's 2d. And 4 times what will give me negative 4? That's negative 1. So if I took this and factored it again, distributed again, then I should come up with my 8d minus 4. And if I were to distribute, I would come up with 8d and negative 4. I could take this information that I just found and use it to create my second equivalent expression. If I have 4 times 2d minus 1, then that is the same thing as taking 2d minus 1 and adding it 4 times. I now have two equivalent expressions for 8d minus 4. We now want to read the problem below and then explore whether or not the expressions are equivalent. We say that Miss Lim asked her class to find an expression equivalent to 7 minus 3 times 4 minus 2x minus 10x. One step in each of the following students' work is incorrect. Find and explain the error, then write your own expression equivalent to the one given above. So if this were me working the problem, I would look at my expression and simplify it myself so I know the correct steps to take. And if I have 7 minus 3 times 4 minus 2x minus 10x, then the first thing I would need to do is distribute a negative 3. So negative 3 times positive 4 is negative 12. Negative 3 times negative 2x is a positive 6x. And then I'll bring down my negative 10x and my 7. At this point, we can see that 7 and negative 12 are like terms. 6x and negative 10x are like terms. So 7 minus 12 is negative 5, and 6x minus 10x is negative 4x. So the expression should be negative 5 minus 4x. Now I can look at what John did, and I can see that John started this problem by subtracting 7 minus 3 to get 4. That's where his error was. He should have distributed. For Madison, I'm looking at her problem and I can see that she incorrectly combined like terms. She went ahead and combined 4 minus 2x to create 2x. But those terms are not alike, so you can't do that. You would have to distribute the negative 3 first. Selena, looking at her problem, we can see that she did distribute negative 3 to positive 4. But she did not distribute negative 3 to negative 2x. So she incorrectly distributed. So if we make some connections about what we just did, the mistake that John did was he didn't follow the order of operations because he subtracted first. Madison made a mistake when she combined terms. Explain the mistake that Madison made. So she incorrectly combined unlike terms. Or she incorrectly combined like terms. Because they did not both contain the variable. Selena didn't use the distributive property correctly. Where did she go wrong? And explain your thinking. When Selena went through and did the distributive property, she did not distribute to both terms. Now we want to write an expression that is equivalent to 7 minus 3 times 4 minus 2x minus 10x and show our work. We did that when we started the problem to help us make sense of it. So we take our 7 minus 3 times 4 minus 2x minus 10x and we start with distributive property. Negative 3 times 4 is negative 12. And negative 3 times negative 2x is positive 6x. bringing down our negative 10x and our 7. Now we can combine like terms. 7 minus 12 is negative 5, and 6x minus 10x is negative 4x. So our simplified answer is negative 5 minus 4x. Number 13 asks, how can you be sure you've used the properties of operations correctly to form an expression that is equivalent to its original one? We could evaluate it for some number. I may choose x as 1. If so, when I evaluate both expressions, I should come up with the same number. So 7 minus 3 times 4 minus 2 times 1, because I'm substituting in 1 for x, minus 10 times 1 will give me a number. So I'll need to follow my order of operations. And first I'll do 4 minus 2 times 1 leaves me with 4 minus 2. Bring everything else down. I'll now take care of my parentheses again, and 4 minus 2 is 2, bringing everything else down. I'll now take care of my multiplication in order from left to right. So negative 3 times 2 is negative 6. And negative 10 times 1 is negative 10, bringing down my 7. And 7 minus 6 is 1, minus 10 is negative 9. So now if I were to evaluate my negative 5 minus 4x, I should get negative 9. And negative 5 minus 4 times 1 gives me negative 5 minus 4, which is negative 9.